So we spent a lot of time here lately working with logarithms and using logarithms to help us solve exponentials. Uh, Today, what we're going to look at is kind of thinking back to our exponentials a little bit, and not necessarily using logs with them, but thinking about if we have certain pieces of information, how can we find the equation of an exponential function? And then if we had to solve an equation dealing with that exponential, then we know we could use logarithms. So let's say I was faced with this situation. I'm told that I want to find the equation of the exponential function. I know 2 points that it passes through, and then I'm told this extra piece of information. And the extra piece is that it has an asymptote of y equals 0. Well, this extra piece of information has actually been kind of assumed on the problems we've done in the past because I need my pen to work. There we go. Because all of our equations were just in the form y equals a times b to the x power. And we didn't worry about whether we had shifted it from an asymptote of y equals 0 or the x-axis or not. Excuse me. So in this case, because we do have an asymptote of 0, we wouldn't add it on here ordinarily if it's 0, but technically that means I have a plus 0 here because I haven't shifted it up or down. But like I said, in most of the problems we've done so far, this part didn't really factor in. So we just focused on the y equals a times b to the x. And we talked about different strategies for this. One of them, though, was to plug in the values that we had for our ordered pair. So maybe I plugged 392 in for y. I plugged 23 in for x. And then the second point or the other point, I plug in, I'm going to plug in 200 for y and 21 for x. And this system, we decided an easy way or a fast way to solve it was to divide those two, because that way we could eliminate the a's. So if I did 392 divided by 200, I get 1.96. A divided by a would cancel, and then b to the 23rd over b to the 21st. I'd subtract those two and I get b squared. So to find my b value here, I'd square root both sides, and whatever the square root of 1.96 is, 1.4, was our b value. And then just like any other system, we would plug that back in and figure out what our a value is. So maybe I plug it into the second equation. I don't know a, but now I know b is 1.4. That was to the 21st power. So to solve for a, I'm going to divide by 1.4 to the 21st. And so for this example, my a value is, oops, I think I typed that in wrong, 200 divided. Okay, so our a value comes out to be approximately 0.17. So the equation of my exponential here is y equals 0.17 times 1.4 to the x power. So we did a lot of problems like that previously. What I want to look at now is, well, what if things have been shifted a little bit? What if I still want to find the equation of the exponential? I still know 2 points that it passes through, but this time I'm told that it has an asymptote that is y equals 10. So I still want to find the equation of an exponential. We still want to find it eventually in this form, y equals a times b to the x. But now that asymptote has been shifted up 10. Or in other words, I know for sure I have a plus 10 on the end. Well, really, things aren't going to change too much as far as how we're going to attack this. I'm still going to take the points that I'm given, and I'm going to plug those in for y and for x. So I'm going to plug in 11.25 for y, and I'm going to plug 4 in for x. Notice that's the second point that was listed there. I'm going to plug in 12.5 for y, and I'm going to plug in 3 for x. And that was the first point. Now, it doesn't technically matter which one I use first. I always like to use the one that has a larger x value because I know eventually I'm going to have to divide. However, I don't want to do my division yet because I have this ab to the fourth and down here ab cubed, but both of them have that addition of 10. So before I get to my division step, I want to go ahead and subtract 10 on the first equation. So now I'm going to have 1.25 that equals ab to the fourth. And I'm going to subtract 10 on the other one, so that means 2.5 is equal to ab cubed. And now it looks like what we were doing earlier. So I'm going to divide these two and figure out, first of all, what my b value is. Well, if I take 1.25 divided by 2.5, that's going to be a half. A divided by a will cancel. This one works out kind of nice because b to the fourth over b cubed is just b. So I've got my b value. And again, I'm going to plug that back in, figure out what my a value is. So maybe I go to the second equation, and it doesn't really matter which one I go to. This time I'm going to divide by a half cubed. So if I take 2.5 divided by a half cubed, I get 20. And so now I can write my equation. So my equation for this exponential would be y equals 20 times a half to the x power plus 10 because of that asymptote. So really it's no different than what we did before. We just have to keep in mind originally, if my asymptote changes, if I have something other than 0, then I've got to factor that into my equation. All right, so let's read through this situation here and see how we could attack it. This is actually problem 126 from chapter 6, but on this problem it says Janice would like to have $40,000 to help pay for college 8 years from now. Currently, she has $1,000. So there's a few things she's got to figure out. She wants to know what interest rate, when compounded yearly, would help her reach her goal. Well, to help us answer this, they ask certain questions. So the first one is, what type of function would best model this situation? And explain how you would know, and then write the general form of this function. The second thing they want us to do after we figure out what form we should be writing it in is if y represents the amount of money and x represents the number of years after today, you're going to find an equation that models her financial situation and what interest rate does she need to earn. So let's kind of stop there. And what I'd like you to do is I'd like you to work on those two problems there, see if you can figure out what type of function are we dealing with, and then try to figure out what equation that you could use to model her situation. So work on that, pause the video, and then you can come back and see what we should have for those two. All right, hopefully you decided that the best function or the type of function that would model this situation was the exponential, which probably wasn't a shock since that's what we just talked about. Well, if it's an exponential, we know we're going to have this in a times b to the x form. But what we had to figure out is what's the interest rate that she is going to need to earn. So remember, we want to end up with $40,000. We know that currently she has $1,000. And we want to know, or we know that this has to happen in 8 years. So if we think about where she wants to get to, she wants to get to 40,000. We know she started at 1,000. We know a certain amount of growth, or a B value, after 8 years will help her get there. So one way you can figure that out is to set up this equation. 40,000 is equal to 1,000 times b to the 8th. So if I divide both sides by 1,000, I now have 40 that's equal to b to the 8th. And if I do the 8th root of 40, I'll know what my b value is. So the 8th root of 40 is approximately 1.59. So the equation we need is y equals 1,000 times 1.59 to the x power. So what interest rate does she need to earn? Well, 1.59 would mean she's increasing 59%. So she needs to get 59% interest rate. Well, Janice, on the other hand, she was going to start with more money. She's starting with $7,800. She wants to have $18,400 20 years from now. So they want to know, well, what's the interest rate that she needs? Well, essentially, it's the same situation with different values here. So she starts with 7,800. We don't know the growth, but we know after 20 years, she wants to have $18,400. So let's solve this one. Well, if I divide 18,400 by 7,800, I get approximately undo that. I get approximately 2.359. And I'll do the 20th root of that. And I get 1.043, so 1.04. So she needs to earn 4%. So which one's more realistic? Well, you may or may not be familiar with finances, but you can probably guess it's going to be more realistic to get 4% interest versus 59% interest. And that's for a couple reasons. One, she started with more money, plus she had a smaller amount she wanted to get to, and she had more years to get to that amount. So as we're dealing with logs, we just wanted to kind of refresh our memory and remember some things related to exponentials as well.